Dear students, I will now present to you the algebraic expressions of some of the well-known moment-generating functions. Why should we do that? इसकी वजह ये है कि एक बहुत ही इम्पॉर्टेंट प्रॉपर्टी जो MGF की है वो ये है कि अगर आपको MGF पता हो तो आप डिस्ट्रीब्यूशन को आइडेंटिफाई कर सकते हैं. यानी an MGF uniquely identifies the distribution. So therefore, it is worthwhile to have an idea about the algebraic expressions of the MGFs of various well-known distributions. Let us start with discrete distributions. First and foremost, let us consider the Bernoulli distribution. The Bernoulli distribution, as you know, is the one in which the random variable x assumes only two values, 0 and 1, and the probability of x being equal to 1 is p, whereas the probability of x being equal to 0 is 1 minus p, which is also denoted by q. तो ये जो डिस्ट्रीब्यूशन है स्टूडेंट्स, इसका जो MGF है that is given by q plus p e raised to t. q plus p e raised to t, as you can now see on the screen. अगर हम q ना लिखें, हम 1 minus p ही लिखना चाहें, तो then of course we will write 1 minus p plus p into e raised to t. इसके बाद let us talk about the binomial distribution. आप जानते ही हैं कि binomial distribution में we have not just one parameter p, but we have two parameters n and p. n is the number of trials. और ये भी जानते हैं कि अगर हम n को 1 कर दें, तो then we get back to the Bernoulli distribution. तो जो बाइनोमियल है जिसके अंदर n और p दोनों हैं, उसका जो MGF है वो क्या है? As you can now see on the screen, it is q plus p e raised to t, and this entire expression raised to n. अब फिर देख लीजिए कि इस एक्सप्रेशन में भी अगर आप n को 1 कर दें तो आपको एग्जैक्टली वो एक्सप्रेशन मिल जाता है जो कि बर्नूली डिस्ट्रीब्यूशन के MGF का है. इसके बाद let us talk about the negative binomial distribution. The negative binomial distribution, if it has parameters r and p, then the expression of the MGF is given by 1 minus p whole raised to r over 1 minus p e raised to t, and this whole thing raised to r. इसके बाद geometric distribution को देख लेते हैं. The geometric distribution, which is also well known, उसका जो MGF है, उसका expression है p into e raised to t divided by 1 minus q e raised to t, where q itself is given by 1 minus p, and this expression will hold for all those values of t which are less than minus log natural of 1 minus p. Students, इसी तरह we can look at the expression of the MGF of the Poisson distribution. The Poisson distribution, as you know, is also a very, very important and well-known distribution. और इसका जो MGF है, that is given by e raised to lambda and lambda multiplied by e raised to t minus 1. Let me say it again. E raised to lambda into e raised to t minus 1. आप जानते हैं कि पॉइसन डिस्ट्रीब्यूशन का एक ही पैरामीटर होता है, लैम्डा, तो वही है उसके अंदर, और t जो है वो तो इसलिए है कि we are talking about the MGF जिसकी बेसिक डेफिनेशन ही वो है कि जिसके अंदर t इन्वॉल्व होता है, the expected value of e raised to tx. Let us not forget the uniform distribution, the discrete uniform distribution defined on AB. इसका जो MGF है, that is given by e raised to at minus e raised to b plus 1 into t over b minus a plus 1 multiplied by 1 minus e raised to t. So it may not be easy for you to memorize all of these very quickly, but definitely over the course of time, if you work with them again and again, आपको उसका आइडिया बेहतर से बेहतर होता जाएगा और फिर एक वक्त आएगा कि you will have memorized it also. It comes in very handy. It is very useful कि आप MGF आपको दिखे, आप कोई डेरिवेशन कर रहे हों एडवांस्ड और वो फिर MGF की इस किस्म की शक्ल आए तो आप फिर इमीडिएटली आइडेंटिफाई कर लेंगे कि ओके, सो आई एम dealing with this particular distribution. Let me also give you the algebraic expressions of the MGFs of some well-known continuous distributions. So first of all, the continuous uniform distribution, which is also called the rectangular distribution. Defined on AB, agar ye ho, so then the MGF for this one is given by e raised to tb minus e raised to ta over t multiplied by b minus a. Iske baad, let us consider the most important normal distribution. Normal distribution के आप जानते ही हैं कि दो पैरामीटर हैं, mu and sigma, या हम कहते हैं म्यू एंड सिग्मा स्क्वायर. और इसका जो MGF है ये तो आपको बिल्कुल ही याद कर लेना चाहिए. इसका MGF जो है दैट इज गिवन बाय e raised to mu t plus half sigma square t square. E raised to mu t plus half sigma square t square. Let us consider a few more distributions. For example, the exponential distribution with parameter lambda. Iska jo MGF hai, that is given by 1 minus t into lambda raised to minus 1 and this whole thing raised to minus 1 under the condition that t is less than lambda. ये जो मैंने अभी कहा इसको आप दूसरे तरीके से भी लिख सकते हैं. You can say that it is 1 over 1 minus t over lambda. So उसको लिखने के मुख्तलिफ तरीके हैं, वर्जन बन सकते हैं. Let us consider the gamma distribution with parameters k and theta. इसका जो MGF है उसका expression क्या है? 1 minus t theta and this whole thing raised to minus k. And this will hold for all those values of t which are less than 1 over theta. इसके बाद let us consider the chi-square distribution. The chi-square distribution with parameter k, or let me say with k degrees of freedom. इसका जो MGF है उसका expression क्या है? 1 minus 2t and this whole thing raised to minus k by 2. Let us consider one more distribution, the Laplace distribution with parameters mu and b. The MGF is given by e raised to mu t over 1 minus b square into t square. Last but not the least, for this description that I'm giving you of various MGFs of well-known distributions, let us consider the Cauchy distribution. Well, my dear students, it turns out that for the Cauchy distribution, the MGF does not exist. So this is the story of MGFs of well-known distributions.